Hello students, I am Ashish De. I am taking one of your subject, that is signal and system. In my earlier video, I have discussed about introduction to Laplace transform. In this video, I want to discuss about S-plane. Okay, now in Laplace transform formula, we know Laplace transform of any function x t is defined by this relationship and it is denoted by x of s. So Laplace transform of any function xt is denoted by capital X of s. Now what is the formula of Laplace transform? In case of bilateral Laplace transform, the formula is integration over minus infinity to infinity x of t into e to the power minus st dt. Okay, but in case of unilateral Laplace transform, the formula is, so this is bilateral Laplace transform, right? And for unilateral, in case of unilateral Laplace transform, the formula is xs equal to integration over 0 to infinity. Okay, 0 to infinity, it is not from the minus infinity to infinity. Okay, so 0 to infinity x of t into e to the power minus st dt. Okay, so this is unilateral Laplace transform. It is valid only for causal signal when xt is causal, right? Now here the term s equal to sigma plus j omega. We know that sigma plus j omega. Okay, so s is known as complex frequency. The name of s is complex frequency. Just remember this. Okay, now what is sigma? The name of sigma is attenuation constant. Okay, and the unit is Nipar per meter. The unit of attenuation constant is Nipar per meter. And what is omega? Omega is nothing but angular frequency. Okay, what is the unit of angular frequency? That is radian per second. Okay, so we know the relationship between angular frequency and normal frequency, that is expressed in hertz. So what is the relationship? Omega equal to 2 pi into f. Okay, so this is the relationship between angular frequency and normal frequency f. Okay, the unit of f is in hertz. Okay, now we are just concentrating about the term s, that is known as complex frequency. Okay, here we can see the real part of s is sigma. Okay, and imaginary part of s is omega. Okay, since it is a complex quantity, it can be expressed by a coordinate system. Okay, and that coordinate system is this. Along x-axis or along horizontal axis, there is the real part of s, that is sigma. Okay, and along the y-axis or vertical axis, we have the j omega part, imaginary part of s, right? And this is the origin of this coordinate system. Okay, and this coordinate system is known as S-plane. Okay, S-plane. Since s is a complex quantity and the real part of s is written here along x-axis or horizontal axis, and the imaginary portion of s is written here along y-axis or vertical axis. That's why this is called S-plane. Okay, so the horizontal axis of this plane is known as real axis since it is defined by S equal to sigma plus J0, sigma plus J0. So this real axis or sigma axis is defined by sigma plus J0, okay, and vertical axis is defined by 0 plus J omega. We all know this thing, okay. Now when we do Laplace transform of any function xt, that is xs can be represented by a fraction like this way, okay. Xs equal to, it has some numerator portion that is denoted by ns, and it has some denominator portion that is d of s, okay. Obviously numerator is the function of s and also the denominator is also the function of s, okay. Now it can be represented, ns or numerator portion is represented by a polynomial, that is b subscript m s to the power m plus b subscript m minus 1 into s to the power m minus 1 like this way, plus b1s plus b0, okay. So this is the numerator polynomial, and denominator polynomial, suppose this is s to the power capital N plus a n minus 1 into s to the power n minus 1, okay, plus dot dot plus a1s plus a0, right. So this is the fractional portion, it is basically a fractional portion and is denoted by x of s, okay. So here we can see that the numerator portion, the numerator polynomial having the degree of capital M, and denominator polynomial having the degree of capital N, right. Now when we put this numerator polynomial equal to 0, all the values of s by putting this numerator polynomial equal to 0, that are known as zeros of xs, zeros of the function xs, okay. Again, if we put the denominator portion is equal to 0, we have some values of s that are known as poles of the function xs, okay. So what are pole? Pole are basically the values of x, all the values of s when the denominator of xs equals to 0, okay. Again, what are zeros? Zeros are basically the values of s by putting the numerator of xs equal to 0, okay. Just remember this thing, okay, how to calculate 0 and how to calculate poles, okay. So from this video what we learn? We learn about the s plane. S plane, since s is a complex number, it has some real part and some imaginary part. Real part, if we put real part along x axis and imaginary part along y axis, that is j omega along y axis, then this coordinate system is known as s plane, okay. Now we know the name of the real portion, that is attenuation constant, and the name of imaginary portion, that is angular frequency, okay. We also know the relationship between angular frequency and normal frequency, that is f, okay. Again, we know about what are pole and what are zeros,